Okay, now we move on to the infraclass Metatheria of the subclass Theria, the mammals. We really need to be looking at your lab manual here as we move along to this. Hopefully, most or all of you by now have a copy of the Kelt and Patton lab manual and can be following along in the lab manual. If you do, you'll see that the subclass Theria is divided up into the infraclass Metatheria, also known as the Marsupialia, if you wish, and the infraclass Eutheria or Placentalia. Okay, but we're going to be dealing with today just the Metatheria or the marsupial mammals. And there are 7 orders of them, but we're only going to deal with 4 of them. The other 3 we don't have any bone clones of them or any specimens of them, and they're not very speciose orders. However, I am giving you a table. I'll be giving you by now you'll have the PDF of this table listing the 7 orders of Metatherian mammals. And there are 2 characters that you'll see that are used to separate Metatherian mammals into various groups, and those are related to foot structure and tooth structure. So let's talk about foot structure first, and this typically relates to the hind feet, and it's a condition known as syndactyly, and it's where the second and third digits are, for want of a better word, stuck together, whether they're stuck together or not, and that condition is known as syndactylous. And if they're not stuck together, it's referred to as didactylous, or sometimes you'll see it referred to as polydactylous, a kind of a more normal condition that you would see in, quote, regular mammals. So a number of the marsupial orders, especially the Australasian orders, are syndactylous. They have this fusion of the second and third digits of the hind feet, usually. And you notice I talked about Australasian orders because marsupials are found from North America through South America and into Australia and parts of Southeast Asia as well. So here you'll see we're looking right at our own possum. Well, this is a California possum, but possums are not native to California. But since they are found in California, you need to know a lot more about this species than you need to know about all of the other marsupials, because it is found here. You need to know more about its habitat, its diet, and so on. These are a much maligned species. They eat lots of ticks, and ticks cause Lyme disease. They're harmless. They might hiss at you, but they're also known for a behavior called feigning. They can pretend that they're dead and so on. And they're sometimes referred to as possums, P-O-S-S-U-M, but they're more correctly referred to as opossum, the Virginia opossum. Possum is more correctly used for the Australasian species. And just to get back to the classifications here, we're dealing with the class Mammalia, subclass Theria, infraclass Metatheria, and this is the first order that we're dealing with, the order Didelphimorphia. And this is the first family we're dealing with here, the Didelphidae, and this is the first species, Didelphis virginiana. Now, you might remember I asked you to study up in your book a type of tooth called the tribosphenic molar. And the marsupials have a molar that is like it bears a lot of similarity to the tribosphenic molar. And you can see it here to a certain extent in this possum skull that I've turned upside down, or I should say opossum skull. And this is the upper jaw. And by the way, opossums have many more teeth than eutherian mammals. So you can see he's got 5 incisors on either side, on both sides before the canine, lots of premolars and molars and so on. And also they've got the tribosphenic-like teeth on the bottom as well. Now there's a lot more about this in your lab manual, so I'm going to be referring you to your lab manual as we move through these orders here. But the only species that we're going to look at here for the Didelphimorphia is the American opossum, or the Virginia possum, Didelphis virginiana. Okay, and you need to know that, like I mentioned, the tribosphenic molar. You also have a handout by now as well for this lab, and these orders are presented sequentially in this, and you can cross-reference them with your lab manual and the textbook as well. Like I said, not all of some of the orders that we don't deal with are fascinating organisms as well. And there's more about those both in your lab manual and in the textbook, and I'll touch on them in lecture as well. So that is the order Didelphimorphia. It is didactylous, so that the digits are separate like they would be on your own toes, and they're polyprotodont. I didn't mention what the teeth condition was. Forgive me, I forgot that. Polyprotodont, you can see it here in the lower jaw of this very large opossum skull. Here's a very large skull, and the tooth condition that can separate a number of these marsupials is whether they're polyprotodont or diprotodont. And if they're diprotodont, instead of having a lot of teeth on the lower jaw here of incisors, a lot of similarly sized teeth, as you can see on this one, they'll have 2 big incisors, one on each side, and they'll be protruding straight forward like little spears. Okay, now you'll see those on a number of the other groups that we will be dealing with shortly. But the Didelphimorphia, as you'll see in the table that I'll give you, are didactylous, so they've got, quote, normal feet, and they're polyprotodont, so they've got, quote, normal teeth as well. So again, that's the order Didelphimorphia, a very speciose family of marsupials. There are over 87 species in this order.